Picture shows the radiotherapy machine. The radiotherapy machine is a machine used to destroy cancer cells. Cancer cells are exposed to radioactive radiation in order to destroy them. Do you know what radioactive radiation are? At the end of this lesson, you should be able to name the 3 types of radioactive radiations, describe the characteristics of each type of radioactive radiation, compare and contrast radioactive radiations. We have learnt previously that radioactive decay is a process whereby unstable nuclei breaks down into more stable ones by emitting radioactive radiations. Apart from this, heat energy is also released. There are 3 types of radioactive radiation. They are alpha radiation, beta radiation, gamma radiation. Alpha radiation consists of fast-moving particles that are released by unstable nuclei when they decay. These are called alpha particles. Alpha particles are also known as helium nuclei. Beta particles are fast-moving electrons that are ejected by decaying nuclei. Gamma radiation are also known as gamma rays. Gamma rays are electromagnetic waves with very short wavelengths. Because they are waves, they have no mass and charge. Alpha, beta, and gamma rays have different characteristics. Observe the animation. What can you deduce about the penetrating power of alpha, beta, and gamma radiation from the animation shown? The animation above shows that gamma rays has high penetrating powers followed by alpha and beta radiation. Let us observe other characteristics of alpha particles, beta particles, and gamma rays. Alpha particles have low penetrating powers and can be stopped by a piece of paper. Beta particles have moderate penetrating powers and they can be stopped by a thin aluminium sheet. Gamma rays have high penetrating powers. They can be stopped by lead or concrete blocks. Alpha particles have very high ionizing power. Beta particles have lower ionizing power than alpha particles. Gamma rays have the lowest ionizing power. Alpha particles have the slowest speed. Beta particles are faster than alpha particles. Gamma rays are the fastest radiation as they travel in the speed of light. We have learned about some characteristic of alpha, beta, and gamma radiations. Let us find out whether they are affected by electric and magnetic field. Observe the animation carefully. Some radiation is affected by electric and magnetic field. Alpha particles are attracted to the negative plate as they have positive charges. Beta particles are attracted to the positive plate as they are negatively charged electrons. Gamma rays are not affected by the electric field. Alpha particles and beta particles are deflected by magnetic field. Gamma rays are not deflected by magnetic field. Drag and drop the correct answer into the tabular column and click the check button to check your answer.
Your answer is correct.
The purpose of this animation is to show the deflection of alpha, beta, and gamma radiations through an electric field. Start the animation by clicking at the radioactive source. After carefully observing the animation, determine the charge represented by P, Q, and R. Key in your answer in the spaces below. Can you name the type of radiation represented by P, Q, and R? Now, fill in the passage below with suitable words. Click on the correct answer. The alpha particle is A. An electron, B. A helium nucleus, C. A negatively charged ion, D. An electromagnetic wave.
Your answer is correct.
Which of the following material is the most suitable to make a box for storing radioactive substance? A. Lead, B. Glass, C. Wood, D. Aluminium.
Your answer is correct.
Which of the following statement is true about beta radiation? A. It is negatively charged. B. It has strong ionizing power. C. It is not deflected by an electric field. D. It can only be stopped by a block of concrete.
Your answer is correct.
Why are gamma rays not deflected by a magnetic field? A. Gamma rays have no mass. B. Gamma rays have no charge. C. Gamma rays have low ionizing power. D. Gamma rays have strong penetrating power.
Your answer is correct.
Which of the following statements are true about gamma ray? 1. It travels with the speed of light. 2. It has a strong penetrating power. 3. It can be stopped by a 3 mm thick aluminium sheet.
Your answer is correct.
In this lesson, we learnt that there are 3 common types of radioactive radiations, namely alpha, beta, and gamma. All 3 types of radiations have different charges, speed, penetrating power, and ionizing power. The radioactive substances will lose their activity with time in the radioactive decay process. The decay is measured in half-life, which is the time required for the atoms of radioactive substances to reduce to half. The half-life of some of the elements are shown in Table 1. Which radioisotope listed in Table 1 would you choose as traces for diagnosis and treatment in medical work? Explain your answer. Why are alpha particles not used in radiotherapy? Technetium-99 because it has a half-life of 6 hours, which is long enough to examine metabolic processes, yet short enough to reduce the radiation effects to the patient. Alpha particles is not used in radiotherapy because it has strong ionizing power that can damage human tissues.